Hello, today I'll go through a couple of problems from Physics in Focus 11. The first problem is this. A 5-liter tub contains 3 liters of water at 23 degrees Celsius. The tub is then filled to the top with hot water. The final temperature of water in the tub is 26 degrees Celsius. What was the temperature of the water added? So something that we have, let's see, we have a container, and the container can have 5 liters of water maximum. Then we added 3 liters of water with temperature of 23 degrees centigrade. So if I name this one sample A or water A, after that we fill the container with hot water. It means we added 2 liters of water, hot water to that. What's the temperature of this one? This is something that we are going to find. And if I name this one B, so 3 liters of 23 degrees Celsius water and 2 liters of, we don't know what temperature, but we know it's hot water. And T equilibrium is 26 degrees Celsius. Right now, something that we want to find is temperature of hot water. So we have, let's say we added some water, and on top of that we added hot water, and then they mixed and they got to the point that is thermal equilibrium. So it means hot water losing energy or heat energy, and cold water gaining energy. But the amount of energy that cold water gains is equal to the amount of energy that hot water loses. So it means the magnitude of energy gain is equal to the magnitude of energy lost by hot water, but definitely one is positive and this one is negative. So if we add Q1, if I name this one QA and this one QB, it means QA and QB are equal in magnitude. But definitely QA is positive because it gains energy, QB is negative because it loses energy. As a result, I can say QA plus QB is equal 0. Right now, what's QA equal? QA equal MA CA T final, that is T equilibrium, minus initial T. QB is MB CB, again T final, that is T equilibrium, minus initial T for that. The sum of that is 0. But what's MA? We don't have mass. The only thing that we have volume, but is water. And for water, we know the density for water is equal 1 gram per centimeter cube, or it's 1 kilogram per liter. So it means when we say 3 liters of water, based on the 3 liters of water, it's 3 kilograms. So the mass of this one, actually, it means its M is 3 kilograms. So I put 3. And because it's water, so C water in the question we have it is 4186 T, and this one is delta T, and we know just delta T always is T2 minus T1. So for both of them, T2 is T equilibrium. So T equilibrium is 26, and T1 for this is 23 plus. MB, Again, it's 2 liter, but because it's water, so it means it's 2 kilogram. C is 4186, 26 minus Ti that we don't know, we want to find. Okay, so right now just we need to do calculation. Times in this one is equals 3, and times and simplify everything, then we get 25 5 3 4 6 equal 8 3 7 2 Ti. As a result, we get Ti equal 30.5 degrees Celsius. Second question, a 60 kilogram bushwalker is suffering from hypothermia, having an average body temperature of 33.5 degrees Celsius. Okay, so the temperature, just I write this one here, T equals 33.5 degrees Celsius. When rescued, the bushwalker was wrapped in a blanket and given 2 310 milliliter cups of warm tea. Okay, so I write just I summarize all data, 2 times 310 milliliter hot tea. And temperature of hot tea, just I write T equal 60 degrees Celsius. So just this one I write T body, then we don't have to read the question again. Calculate the maximum rise in the bushwalker's body temperature due to the heat of tea. Okay, we want to see how much heat energy transfer from tea to the body of bushwalker. And we have C for human body, and we have C for water here. Let's see what's happening here. And the bushwalker is 60 kilogram. So M body, I can say, equals 60 kilogram. Let's see what we have here. So we have the bushwalker that has very low temperature, and we have tea that has high temperature. So something that happened, we know always heat energy goes from hot substance to cooler substance. So right now, the direction of movement of heat energy is from T to the body. But the amount of heat that T is losing actually is equal the amount of heat that the body gaining, the bushwalker gaining. So again, like the last question, the amount of heat is equal in magnitude, but definitely this one is negative because losing energy, and this one is positive because it's gaining energy. So I write the Q, let's say bushwalker. So I write bush plus Q. T should be equal 0. Right now we know Q equal MC delta T, or I can say MC T2 minus T1. Yeah. And something that we want to find, let's see, calculate the maximum rise in bushwalker's body. We want to see at the end how much temperature of bushwalker body increases. So it means we want to see what's first, we should find what's T equilibrium here. We need to find T equilibrium. So I say, okay, Q for bushwalker is M for bushwalker times its side. It's C times T equilibrium, that is final temperature, minus initial temperature for Bushwalker, plus, and I put B Bushwalker, and then for T again is M for T, C for T, that is the same as water, C for T, and then again is TE for T minus T initial for T. There equals 0. M Bushwalker is 60. Okay. C is 3.5 10 to the power 3, as you can see in the question. T equilibrium is something that we want to find. That is T equilibrium with this one is equal to this one. So instead of writing T and Bushwalker, just I write TE. T initial for Bushwalker was 33.5 plus MT. We don't have mass of T, but we know we had 310 milliliter cups of tea. So it's equal 620 milliliter. And we know density of water is 1 gram per milliliter. So it means 620 milliliter of tea or water is equal 620 gram. So it's actually like 620 gram that we need to convert it to kilogram, because mass here should be in kilogram. That is equal to 0.62 kilogram. So this is mass of tea. Just I put it in brackets, 620. C40 is like water, because most of it is water. So 4186. TE is something that we want to find, and TI was for T was 60. And then it's equal 0. So after that, I need to times this, do calculation, and I get a number here, times it by TE, minus this number times by this one. And then you do all calculation, and you see just we have one unknown, and that one is our TE. So when I do calculation, I get 212,595.3 TE equal 719.2. As a result, TE equal 33.82 degrees Celsius. But if you look at the question, they haven't asked us to find just T. They haven't asked calculate the maximum rise in the bushwalker's body temperature due to heat of T. So T equilibrium between T and body is this one. The initial body temperature of the bushwalker was 33.5. So what's the change of temperature as a result of T is 33.82 minus initial temperature, that was 33.5, that become equal 0.32 degrees Celsius. I hope it helped, and bye for now.